Hi class, I'm going to run through as many examples as I possibly can from sections 11.1 and 11.2, following directly from your notes. So, slide 2, we have to find the area of this parallelogram. We know it's a parallelogram. Well, it's not marked in the picture on your notes, but let's assume that it says, assume this is a parallelogram, find the area. So we know the area formula for parallelogram is base times height. We've got a lot of numbers going on here. So first thing I want to point out is they try to make the parallelograms look confusing. Anytime you see a dotted line, that is not a part of the figure that you're finding the area of. That's usually an indication that they're trying to give you the height. So in this case, it gives you two different heights. 8 is a height and 4 is a height. And we know that those are heights because they are perpendicular to the bases. 8 is perpendicular to this base, and 4 is perpendicular to this base. So base in geometry does not always mean bottom, and that's where people get a little tripped up. When we're finding the area, the base is not always going to be the bottom side. So there's actually two different ways we could find the area for this parallelogram. We can use this base with its corresponding height, or we can use this base with its corresponding height. So to find the area of this parallelogram, we can either take base times height, 6 times 8, which is 48, or this base times the height that is perpendicular to that base, which is 4. 12 times 4 is also 48. So either way would have been an acceptable way to find the area of that parallelogram. You just have to sort through which bases go with which heights, what's perpendicular to each other, sort through all of the dotted lines to kind of figure out what information you really need to know. And then make sure this one doesn't have units, but if it did, make sure we're squaring our units. So 48 units squared. Same slide, next two examples, we'll go through these a little bit quicker. We are finding the perimeter and area of these figures. So the first figure is a triangle. When we're finding the perimeter of a figure, we're just adding up all of its side lengths. So triangle has 3 sides. The side lengths are 17, 10, and 21. When we add those together, we get 48. So our perimeter would be 48 units, since it doesn't give you units there. When we're finding the area of a triangle, we use the formula 1/2 base times height. Now the height that it gives you is 8. We know that that's the height because of this perpendicular mark right there with the 8. So if 8 is the height, that means 21 is the base because they are perpendicular to each other. So we would have 1/2 of base times height, or 84 units squared. So perimeter was units, area, units squared. All right, next picture. We've got a parallelogram. We know it's a parallelogram because it marks that these two sides are parallel and those two sides are parallel on your notes. To find the perimeter, again, we're adding up all the side lengths. We have 30, 20, 30, 20, and so when we add all this together, we get 100 units as our perimeter. And then finding the area, we only have one height for this parallelogram. It gives us a height of 17, which is perpendicular to this base. So if we take base times height, that's 17 times 30. And our answer then would be 510 units squared. So perimeter was 100 units, area 510 units squared. For the last example on that slide, again, we're finding the perimeter and the area. This time we've got a triangle, but we're missing one of our side lengths, and this side length is important both for the perimeter and for the area. So we need to find that missing side length. Luckily, it's a right triangle, and we know 2 of the side lengths, so we can use the Pythagorean theorem to get the third. So a squared plus b squared equals c squared. In this case, our c squared, or our c, is 13. That's our hypotenuse. It's across from the 90-degree angle. So we have 5 squared plus x squared, the side we don't know, equals 13 squared. When we solve this, we get x squared equals 144, which means that missing side length is 12. So now that we know all the side lengths of that triangle, we can add them together to find the perimeter. If I take 5 plus 13 plus 12, that's 30. So our perimeter is 30 units. And then if we're finding the area, we would use the formula 1/2 base times height. And the base and the height we're going to be using are 12 and 5 because they are perpendicular to each other. So 1/2 of 12 times 5, which is 30 units squared. Next slide, this time we're going to be working backwards a little bit. It tells us that the base of a triangle is twice the height. It also tells us that the area of the triangle is 36 inches squared, and we need to find the base and the height. So first of all, remember, my picture's not always drawn to scale, so you can't trust them. We know the area, so let's start with the area formula for a triangle, 1/2 base times height. And since we know the area, we know that 36 equals 1/2 base times height. Problem is we can't solve for base and height right now because that's two different variables. We can't solve for both of them at the same time. But it does tell us that the base is twice the height. So is in math, remember, means equal. So the base equals twice the height, 2 times the height. So base is equal to 2 times the height, or 2h. So instead of a b right there, we can replace the base with 2h, 2 times the height. So if I rewrite this, I have 36 equals 1/2 of 2 times h times h. And then if I simplify this, I have 1/2 times 2, which is 1, and h times h, which is h squared. So this is just 36 equals h squared. And if 36 equals h squared, that means h is 6. So our height is 6. And now that we know the height, we can plug that in to figure out what our base is. We know the base is 2 times the height. So our base is 2 times 6. Our base equals 12. And these units are in inches. So the height is 6 inches and the base is 12 inches. The last problem on that slide says that we have a parallelogram. It gives us the area is 153, the height is 17, and it asks us to solve for the base. Whenever we have to solve for a missing variable, start by writing down the equation that we need. So this is talking about the area of a parallelogram. So the equation that's going to be the most helpful to us, or the formula that's going to be the most helpful to us, is area equals base times height, because that's our area formula for a parallelogram. And we know the area is 153, so I'm going to plug a 153 in. We do not know the base, but I know the height is 17. From here, it's just a simple equation that we're solving. To get b by itself, we're going to divide both sides by 17. When I take 153 divided by 17, I get 9. And my units for the base would be inches. 9 inches. Fourth slide, we are painting the side of the barn, and we're going to assume that we're only painting what's highlighted there. So we're not going to paint the whole barn, we're just going to paint this front side. We're going to paint that triangle on top along with this rectangle on bottom. And we want to know how much paint we need to buy. And it says 1 gallon is equal to 350 square feet. Or 1 gallon covers 350 square feet. So since we're talking about square feet and we're talking about painting something, really we're finding the area of it first. That needs to be our first step. The square, the feet squared or square feet, that should be your clue that we need to find the area. And in this case, we have 2 pieces of area that we need to find. We need to figure out the rectangle, we need to figure out the triangle, then we need to add them together. Rectangle part's easy. We're just going to take 26 times 18, which is 468 square feet for the rectangle. Triangle's a little bit trickier because I should add in the little right angle at the top. It is a right triangle, which is helpful to us, but we don't know the base and the height. It looks like 26 should be the base, but if we use 26 as the base, notice that we don't know what height goes with the 26. The base and the height are actually these two sides up here because they form the right angle. Wherever the right angle is, that's where your base and your height are. So we need to figure out what this length is and what that length is. And right now we know that at least they're the same. This is where we have to draw on that information from a couple of chapters ago when we talked about special right triangles. This is an isosceles right triangle, or a 45, 45, 90 right triangle. We know the hypotenuse, which means our side lengths are 26 divided by root 2. And if you remember rationalizing the denominator, that means that each one of those side lengths is 13 root 2. I'll write that on the other side. 13 root 2. You could also use the Pythagorean theorem on this one to figure out what that missing side length is because they are the same. So that could be another option if you didn't remember those special right triangles. But we've got two side lengths, our base and our height are each 13 root 2. So when we're finding the area of that triangle, we're going to take 1/2 of 13 root 2 times 13 root 2. So we've got 13 times 13 is 169. Root 2 times root 2 is 2. And we've got this 1/2. So the area of the triangle is 169. All right, so we've got the area of the triangle, we've got the area of the rectangle. To find the area of that whole barn side, now we're going to add those two together. When I take 169 plus 468, I get my total area to be 687 feet squared. But that wasn't the question. The question was, how many gallons of paint do we need? So since 1 gallon covers 350 feet squared, and we have 687 feet squared, I'm just going to take 687 divided by 350, and I get basically about 2 gallons is what we would need in order to cover that whole barn side. Now for part 2 of that question, it says, what if we have a 5-foot by 10-foot rectangular window on that barn side? 5-foot by 10-foot. How many square feet are we going to need to paint in that case? So we don't paint a window. So basically, we already found the area of the whole thing is 687. Now we just need to subtract out that window. So if it's a 5-foot by 10-foot window, then that's a 50 square feet window. I'm just finding the area of that rectangle there. So my original total area was 687, but now we're going to subtract 50 from that. And so the area we would need to paint if there was a window would be 637 square feet. This video is getting a little long, so I'm going to go ahead and make a second video for the back side of those notes.